Southampton in 1997. Then went on to be a postdoctoral scientist at Columbia University and the Scripps Institution for Oceanography, and joined the faculty at the University of Miami's Rosenstiel School of Marine and Atmospheric Science in 2003. Lisa's research focuses on ocean circulation and property transport, particularly within western boundary currents in the Indian Ocean. She is actually one of the leading experts on the IndOOS system of currents off South Africa, and has brought recognition to the key role the system plays in warming climate through her publications in international leadership. In addition to her wealth of knowledge with respect to these systems, she is extremely active and engaged in the community to work to increase the engagement, recruitment, and retention of women and minorities in oceanography, such as the group called Empower. Her publication records through the roof. She's participated in 17 scientific voyages to the Atlantic and Indian Oceans, totaling, I'm amazed with this, 358 days at sea, planning and leading 7 of these voyages as chief scientist, and she's published over 50 peer-reviewed scientific publications. Similarly, her awards and leadership positions are extensive, including but not limited to chair of the Scientific Committee on Oceanic Research, or SCORE working group, co-chair of the CLIVAR IOC, the Indian Ocean Regional Panel, and member of the GOOS Ocean Observations for Physics and Climate Panel. We are so over the moon to have Lisa as one of our speakers today, given our priorities of the U.S. CLIVAR POS panel to engage in the planning review of new and existing observing systems. And today, Lisa is going to talk about the Indian Ocean observing system called IndOOS. So thank you so much, Lisa.
Thank you, Michelle. Thank you for inviting me. And it's great to have a platform to share some of this work that the Indian Ocean community did together over the past 3 years. And in 20 minutes, I'm going to be able to give you only a little taste. And I really encourage you to take a look at the whole report. There is an 8-page summary at the beginning of the report, so that you don't have to read the whole 200 pages. It gives you a nice rundown with a little more detail than you're going to get today of exactly some of those recommendations that we came up with during this 3-year review process. So with that, let me see if I can remember how to share my window here. Okay, can everybody see this opening slide?
Yep, you're good.
Yeah.
Okay, great. So this is a cartoon. Actually, it was drawn up by our partners at JAMSTech, and really to depict, what the Indian Ocean Observing System is about for everybody else besides oceanographers and climate scientists. Of course, our observing systems serve society, and they serve people in agriculture and farming, for example, water resource management, fisheries, marine transportation. And you can imagine that around the Indian Ocean, we have quite a unique set of developing nations, which means a lot of vulnerability. The picture on the left here, this is kind of, this is the cover page of the whole report. And I encourage you to go take a look. I'll put up the DOI again at the end. It's all published. It was published in December 2019. And you're welcome to encourage you to go take a look. So I'll emphasize that, while I'm giving this talk, a lot of people, a large community went into this effort. 60 authors and many more people as part of the workshops that we held over the 3 years. And in particular, my fellow editors, Jérôme Veillard and Matthew Roxy, who is co-chair of the Indian Ocean Region panel. So what's the mission of an observing system like the Indian Ocean Observing System? It's to provide sustained high-quality oceanographic and marine meteorological measurements that support knowledge-based decision-making through improved scientific understanding and ultimately through improved weather, ocean, and climate forecasts. Why do we need to review this system and perhaps provide a new roadmap forward? Well, the original system was designed back in 2006. And since then, really, a lot of scientific and societal priorities for these measurements, including new technologies, have evolved. And so we need to look again at the practicalities, also of an implementation of the system, and to take into account the increased pace of climatic and oceanic change. So in the review findings, we provide a roadmap that addresses what we think is a clear and urgent need for expansion of the Indian Ocean Observing System, so that it can meet the needs of a broad suite of users over the next decade. So I'm not going to go too heavily into the background of how we went about this review. Again, I encourage you to look at the full report, or ask me questions after this if you want to know more. But just to give you kind of an overview rundown of the effort that went into this, the numbers of IndOOS. This was put together by Jing Li, who I should mention, she's in the International CLIVAR Project Office, and was an absolute rock through this process. And you can see 2,000 plus emails. It was, probably 5,000 plus emails. I don't know. It was a lot of emails, 60 authors, 35 months, so almost 3 years, 25 chapters, a review panel of 6 international reviewers, 3 editors, and 3 workshops. And it led to 136 actionable recommendations. So I'm not going to go through those 136 today, but I'm going to give you a synthesis of the core findings that really floated to the top, coming up in multiple areas of need across these recommendations. I should mention this is a photo from our first workshop, which was held in Western Australia. And I should mention that the Indian Ocean Region panel, with myself as chair, and Jerome, and then Roxy as co-chair over this period, we were joined in this effort by the Cyber panel, which is a biogeochemical and ecosystem research panel. And the chair of that panel is Raleigh Hood, who is standing in the middle of this picture. And so we were very much aware during this process of needing to bring in our biogeochemical colleagues and to really start collecting those observations alongside the physical parameters of the Indian Ocean system. So first of all, in our review, we took a look at what the Indian Ocean Observing System had achieved over its first decade. And of course, there's been some monumental achievements, such as unprecedented knowledge of weather, ocean, and climate phenomenon. Among them, tropical cyclones and marine heat waves have been measured and characterized. We've improved our understanding of coupled convective modes, in particular the Madden-Julian oscillation and the intraseasonal oscillation, the monsoon intraseasonal oscillation, and their influence on global hydroclimate. Mapping of the equatorial and the monsoon circulation, so understanding how the circulations change seasonally in the Indian Ocean. Of course, we have this unique system everywhere north of 10 South in the Indian Ocean basin, where the circulation changes direction with the monsoon winds. So it's really a dramatically unsteady system, and we really learned a lot through sustained observations about those circulations. And we've also started to elucidate the year-to-year climate variations in this basin. Of course, there are links to El Nino, Southern Oscillation, to ENSO, but the Indian Ocean Dipole does have its own initiations as well. And there are also some sort of tropical variability that's intrinsic to the Indian Ocean itself. But of course, we identified some important gaps, and one of these is low prediction skill at subseasonal to seasonal timescales. So you can see on this diagram that we have weather forecasts up to 10 or 20 days, of course, rapidly decreasing in skill as you increase over that time frame. And then we have some predictability out at long time scales associated with seasonal to interannual variability, so such as ENSO and IOD. But in this subseasonal frame, we're really not doing much better than persistence. And for example, if I was somebody in the Indian Ocean who relied on agriculture for my income, and I wanted to know what the rainfall was going to be like during the monsoon next year, then I would have no resource for that. We still know very little, have very little forecast skill in terms of the strength of the monsoons. And the rainfall in the monsoons is heavily influenced by these monsoon intraseasonal oscillations, or the MESOs. And so that's been one of our targets in this review. So another remaining gap is that the climatologies still have large discrepancies. So this is an example of the standard deviation over 6 products of air-sea fluxes for QNet, the net air-sea flux. And so you can see that there are large errors across the basin. And in fact, if you integrate across the Indian Ocean, in each of these different products, we still can't be sure overall whether there's a loss or gain of heat over the basin. So some really fundamental questions are still open here. There's a lack of observations as a part of the original Indian Ocean observing system in the boundary areas. So that's in the Somali Current and in the Sumatra-Java upwelling region near the equator, and then in the subtropics, the IndOOS system itself, close to my heart, of course, and the Lewin Current in the east, which in the Indian Ocean uniquely runs poleward. Okay, so carries water from the Indonesian through flow, largely but not only, and towards the poles. And of course, we have no sustained measurements of biogeochemistry or ecosystems in the Indian Ocean. And it's a region of rapid change, particularly in the Arabian Sea, where fish mortality events have been recurring at faster rates due to rapid growth and upward migration or upward expansion of the oxygen minimum zones there. So why do we need IndOOS-2? I mean, I've talked to a little bit of some of these. There's a lot of people that live around the Indian Ocean rim. It's coming up to about 1/3 of the total world population. A lot of those nations have large vulnerability to, for instance, sea level rise and to increasing cyclone intensity. There are many small island and developing countries in this region which have vulnerabilities due to their dependence on agriculture and fisheries. And if we think about the impact of cyclones in this region, although it only accounts for about 5% of global cyclones, it's been a region that suffered 80% of the global casualties from cyclones. So that gives you an idea of the vulnerability of this region. So we also need these observations because the Indian Ocean has been rapidly warming. Over the last 10 or 20 years, you can see in this chart in the pink curve that it's been warming at about twice the rate of the rest of the world ocean. And it's accounted for about 30% of the global oceanic heat content increase over the last decade. The largest area of heat content changes has been in the subtropics, and the southern subtropics, which is a region that is very poorly measured in the current Indian Ocean observing system. And there's also a decadal increase in the Indonesian through flow, which may be set to change or may have already changed to a decrease, while apparently the IndOOS current doesn't seem to be strengthening. So there's a lot of open questions in terms of the basic heat budget and heat storage in the Indian Ocean, which we currently really can't capture with the current observing system. So we don't know where that heat is going to go. Other motivations are that productivity is in decline around the basin, particularly in the northern regions of the basin. You see in the Arabian Sea here, this is a strong reduction in summer chlorophyll seen over the past 10 or 15 years. And that goes along with an increase in sea surface temperature and a decrease in oxygen levels there. And these fish mortality events are on the increase because of the enlargement of the oxygen minimum zone. So in terms of scientific drivers then, in the Indian Ocean, we have these coupled variabilities, the Madden-Julian oscillation and the monsoon intraseasonal oscillation that I've mentioned before. So these are convective perturbations that originate in the tropical and western Indian Ocean and propagate to the east and north. And in the case of MJO, they can affect global climate. So changes in the Madden-Julian oscillation in this recent paper have been shown to be changing hydroclimate all around the world. And it's been shown that if we can improve our observations of MJO and MESO, if we can improve our understanding of these intraseasonal coupled climate variations, then we can improve our forecast predictions. And you can see in this chart that if you include coupled variability, so coupling between the atmosphere and the ocean, then you can improve your predictions by about 10 days. Other scientific drivers are interannual oscillations, such as the Indian Ocean dipole, the Indian Ocean basin mode, the Indian Ocean subtropical dipole, and the Ningaloo-Nino. These affect rainfall, fish catch, drought, cyclogenesis across the basin. The decadal variability of the Indian Ocean remains largely unknown because the sustained observing system in this basin was only founded around 2006. And so we've really yet to characterize how the decadal variability of the Indian Ocean looks. So if we summarize then the phenomena and scientific drivers in the Indian Ocean basin, we could start with the monsoon circulation and these monsoon currents that change direction with seasons. We have important regions such as the Seychelles-Chagos thermocline ridge region, which couples very strongly with the atmosphere. Also regions of upwelling and regions of mode water formation. We have a heat budget with a double cell overturning heat flux and a horizontal heat flux, which is, the double cell is interesting and it's affected by upwelling off the equator, which is unique to the Indian Ocean. So it tends to connect these upwelling regions off Somalia and Oman with the subtropics in the south. The heat budget in the subtropics is really dominated by the gyre circulation and the Agulhas current, of which we have no long-term measure. The oxygen minimum zones are important scientific drivers, particularly in the Arabian Sea and the Bay of Bengal. We have this region that's affected by intraseasonal oscillations and interannual variability. We have the subtropical interannual oscillations. We have cyclogenesis, which is active both in the northern Indian Ocean and in the west affects Mozambique and Eastern African countries, as well as Western Australia. And finally, we can talk about climate change influence, of course, which is basin-wide on many parameters. Okay, so let's get to then what our findings were from the review in terms of how we move forward to try to fill some of those gaps that I mentioned, and try to fulfill the societal demand for information and predictability. So this is our IndOOS-2, as it were, on this map, and it includes, in green, you can see all the present day Argo floats. In gray, you can see all the present day drifters. In the green squares and triangles and diamonds, you can see the Rama array, the tropical moored array of the Indian Ocean sector. In the blue circles is the tide gauges around the basin. And in the blue bars, we have proposed new boundary current arrays. And finally, in the dashed red lines, they are the ghost ship decadal surveys. Actually, and I missed out the XBT lines, of which you can see two, one across the Indonesian through flow into the basin, and one that crosses the Agulhas and East Madagascar currents on the southwestern side of the basin. The XBT lines, there used to be many more XBT lines, and one of the things that came out of this review was that we could consolidate that down, given the enormous success of Argo, to places where we have boundary fluxes or exchanges which are hard to capture with the Argo array. We also consolidated the Rama array, so we have this Rama 2.0. Which has 13 less sites than the original Rama array. A lot of the sites were cut dependent on logistics of ship time or vandalism. We do have an additional site that we recommended off Northwest Australia, and also these three that are encircled here in the Western Equatorial Indian Ocean, which really have never been occupied because of the threat of piracy in this region. So our first core finding is that the Western Equatorial Indian Ocean coverage needs to be completed with these three Rama moorings that were part of the original plan. Probably one of our most important outcomes is that biogeochemical measurements must be collected alongside physical parameters. This includes oxygen, nutrients, carbon, phytoplankton biomass, and diversity. And these parameters, we believe, should initially be targeted to regions of high variability and change, such as the oxygen minimum zones depicted here, and the upwelling systems. We need to collect enhanced vertical and temporal resolution of upper ocean measurements. So if we want to try to understand the Madden-Julian oscillation and the monsoon intraseasonal oscillation, those coupled climate oscillations, if we want to understand those mechanisms better, we really need better coverage of mixed layer dynamics. And that includes on diurnal scales. And so enhanced vertical and temporal resolution of upper ocean measurements are important, particularly in these two regions that are highlighted, which are regions where the coupling between the ocean and the atmosphere is strongest. So boundary flux arrays, we currently do not have a sustained array in the Agulhas current, and we need to enhance what we have in the Leuven current, which at the moment does not really cover the undercurrent, which is possibly larger than the flow going on at the surface. And we need an enhancement of the Indonesian through flow monitoring system. It's actually very successful, been very successful. This line, IXO1, gives us over 30 years of measurements of the Indonesian through flow, which is a remarkable achievement. From the XBT data, salinity is estimated by using climatological relationships between temperature and salinity. And it's become clear recently that the freshwater flux from the Indonesian through flow can also change dramatically because of changes in rainfall over the maritime continent. And this means that we really think we need to improve our ability to say how salt and freshwater is changing, how the salt load in the Indonesian through flow is changing over time. And with that, we'll need more measurements of salinity. We need more observations of the deep ocean below 2,000 meters. You can see that regions of the southern subtropics are warming the most in the Indian Ocean, and below 2,000 meters, below the extraordinarily successful Argo array, we really have no measurements other than the decadal repeat measurements of the GO ship surveys. And we need more land motion sites. So a lot of the tide gauge sites around the Indian Ocean do not have land motion sites coupled to them. So that means that it's the absolute sea level change is hard to derive at those sites. And we also have a data sharing problem, as you can see in this figure that I show here for the tide gauges in red, where those data are not shared by those countries currently. So beyond the in situ observations, there were quite a few recommendations that came out, and I'll just again summarize some of the top tier ones. Of course, satellite measurements are absolutely central to the Indian Ocean Observing System. So while it wasn't our task to review and recommend future satellites, we wanted to make it clear that the observing system absolutely depends on the satellites as a core part of it. There's also an urgent need for advancements in data assemblage and coupled data assimilation techniques. This is, there's really a kind of disconnect between the observations that are collected and just how useful, how effective they are in the products that the end users are interested in. And so this problem of data assimilation was something that came up several times during our review. There's also an urgent need for increased investment. I'm sure you're thinking, where does the money come from for all these enhanced observations? And so, that's definitely flagged in this review. And we thought that an especially important part of that is the necessity for stronger partnerships with Indian Ocean Rim countries and end users. So I think if we have a hope to not only maintain, but to enhance this observing system into the future over the next 10 years and longer, it's an absolute necessity, particularly in the Indian Ocean Basin, to entrain more of these countries in terms of their investment and in terms of what they get out of the system, in terms of also capacity building with them and making sure that they have the tools to use the information and products that the observing system produces. And of course, along with that goes improved data sharing and commitments to best practices. So it's particularly important for sustained observations of climate when you're looking for small change over time, that you collect the best measurements that you can. So I'll just wrap up with that. I hope I haven't been too long. Minutes. I think I may have been an extra 5, but just to say then that the Indian Ocean Rim countries are becoming more vulnerable as climate change accelerates, and that we hope that IndOOS-2 can provide a fit-for-purpose observing system that leads to improved weather forecasts, climate predictions, and marine ecosystem understanding for the benefit of all. So I'll finish there and welcome questions.
Thank you, Lisa. So if you have any questions, feel free to take yourself off mute and ask your question, or you can type it in the chat box and I'll read it out loud for you. You can also let me know that you have a question in the chat box if you want me to call on you.
Hi, Lisa, this is Shen. I have a quick question. So you mentioned always, it's always the same problem. Where does the money come from to sustain the observations? I was wondering if in your set of recommendations you've identified maybe some partnership with the private sector, specifically in that basin to sustain the observations.
No, that's not something that was part of our terms of reference, but it is something. So moving forward in terms of implementation in the Indian Ocean region, we have an Indian Ocean Resources Forum, and that's made up of leaders of rim country institutions, and in some countries, ministers, so people in politics, and funding managers. And we're really now starting to work with them on how to implement and move forward. So that's part of their task, and they're certainly thinking about partnerships with private industry, including fossil fuel industry, actually, as well as philanthropy. So it's definitely a way. We need to incorporate that kind of thinking into the way forward. Absolutely. I think one of the challenges that we have that's a bit closer to home in terms of us as scientists on the consulting panels, on these panels that try to think about the science and how we move that forward, is the danger of the lack of funding right now, even for our work in overseeing and guiding these systems. And that's something that comes through for the Indian Ocean panel in particular, because half of our funding comes through the United Nations via the Intergovernmental Oceanographic Commission, and the United Nations budgets have been strangled by the United States stepping out of a lot of the support. The United States is stepping out a lot of global support, and that's a major issue. So I think for us being a bit closer to home in terms of things, the way that we can work to help this happen, and in terms of where we are in the US, this is something useful to know and something to lobby about, with our funding managers and politicians, that we really need to step back into these global partnerships to help oversee and be a part of pushing these kind of things forward.
Okay, thank you.
See, we have a question from Chris Pykuch. He asks, are the Red Sea and Arabian Gulf / Persian Gulf part of the scope of IndOOS?
That's a good question. As you can see, it doesn't feature very strongly in this review, neither of those regions. And so, I think the Gulf regions were considered coastal, and although I didn't explicitly mention in this brief talk, other than the boundary arrays, certainly expansion of the observations into the coastal regions, linking the deep ocean with parts of the ocean where people live and people fish and so on, was seen as very important, particularly in terms of biogeochemical and ecosystem measurements and flux measurements. So I would imagine that's something that we could think about, in the future in terms of, enhancing the observations in those regions. But it was not a strong focus, as you can see. I don't know of any Argo floats or drifters that are even in those basins, because I'm trying to think how deep the Red Sea is. Persian Gulf is quite shallow. The Red Sea gets deep enough, but it's probably, anyway, yeah, something we could have looked at maybe a bit better.
And a couple more questions coming through the chat. Fred Bingham asks, how is the Indian Ocean observing system governed presently, and how might that change with this updated system?
The short answer is that won't change with this updated system. The long answer is that how it's governed, or how it's guided is ultimately through the World Meteorological Organization via their World Climate Research Program, and through the United Nations Intergovernmental Oceanographic Commission. And so these two bodies come together to form groups of scientists and experts and stakeholders that come together to, basically form the Indian Ocean Observing System. And the way it works is basically the umbrella of GOOS, right? The Global Ocean Observing System, which falls under the WMO. I mean, you get into just a crazy amount of acronyms when you start this kind of work. And it's quite a tortuous path to really learn how things work. But the upshot is that we don't expect any major changes to that governance. In the Indian Ocean, we already had formed this resources forum because we needed a level above the scientists to really make it work. I think because we have a lot of developing nations to bring on board. But there's a long answer there, because I don't know how familiar you are with WMO or WCRP, but they're going through a lot of change right now. And in fact, WMO is trying to restructure, and I hope it does, because it has an enormously complex structure. And they are, finally taking on the idea that ocean observations need to be operational, just like observations of the weather. And we really need to have, a better kind of institution of funding. For instance, if you think of the US, they have NCAR, UCAR, they have national, kind of overarching bodies that are well funded. But if you think about the ocean observing community, we don't really have a centralized body that's well funded. So that's that again is a challenge in the US. But the World Meteorological Organization is at least realizing now that ocean observations are pretty important. If you want to know anything beyond 10 days about what's going to happen with the weather, you better have some ocean observations, right? So I think we're going to move on in the next decade. I think it's going to be an exciting time, what with those changes, and also the UN decade for the ocean. I think it's going to be an exciting time, for ocean observations, and to try to really move ourselves forward in terms of our organization and our ability to sustain to have kind of the framework upon which we can sustain these kind of observations.
I think we have 2 questions to wrap up this webinar. They're kind of related, and I'm sorry if I mispronounce your name, but Gael asks, what are the ocean reanalysis / data assimilation products regarded as most useful in this community? And then a follow-on question that's related by Sergey, what are the biggest gaps between data assimilation products and the observations / users?
Okay, they're both really good questions that I'm probably not the best person to ask. I'm not sure that it's clear which of the reanalysis products, for example, if you think about those air-sea flux products that I showed, is better or best. Probably a good person to ask that is Lisan Yu. She wrote the chapter on that, and I'd encourage you to go look in the report for more on that. And the second question was about data assimilation. Can you repeat the second question?
Yep. So the second question is, what are the biggest gaps between data assimilation products and the observations and users?
so again, I'm not an expert in data assimilation, I'm an observational oceanographer. That said, through this process of doing this review and hearing experts talk about it, I think the techniques of entraining the observations into, reanalyses, into physical models are still, that's what the focus was on, to improve. That you often find, what you often find is that you collect these extremely important observations of the ocean, right? You have a point measurement, let's say, over time in one place, and it can be really disappointing how much effect those observations actually have in terms of the improvement in predictability, for example. And so that's really the gap. People, and sometimes because of maybe the paucity of coverage or the estimated errors of those observations, they're really not leveraged to the level that they should be. And so that's really, without getting technical, which I can't with you for lack of knowledge, but that's really what's underpinning this need, for improved assimilation techniques. We really need a way to make more of the observations that we collect.
Thank you, Lisa. So I see on the clock it's almost 12:45 p.m. now, so we've held you a little longer, so I think we'll end here. So this webinar is recorded, and I'll share a link with it next week once it's published with everyone in email and through our Twitter account. So for those who are not part of our email community, you can check out our Twitter. So thank you again, Lisa, for giving us the presentation.
Thank you so much for having me.